I'm your man, John Wilson. Today we're going to do Module 7.2 and 7.3. Specifically speaking, we will understand how to solve equations, rational number coefficients and constants, and then we might even use a distributive property to solve real-world problems and situations. What does that mean? First of all, that means we're dealing with something that doesn't look too pretty. We're used to seeing nice, beautiful, crisp, clean equations, something like 2n plus 6 equals 4n plus 15. That's gone, man. Now we are dealing with fractions. The good thing is, I don't feel fractions. I know you probably don't feel fractions, you probably don't like them. I don't like fractions. The good thing is, it's very easy to get rid of all these fractions in one quick step. But to do that, we have to find something. So we're going to travel back in time to when you guys were in elementary school and you're being asked to find something called the LCM. Anybody remember what the LCM means?
Least common multiple.
Least common multiple. We have three fractions here. We want to find the LCM of all three denominators. So my denominators are 4, 10, and 5. The way I find the least common multiple is by starting with the largest denominator. Which one of those three denominators is the largest? Matthew?
The 10.
The 10. So that's the largest denominator. What I need to do now is I need to find the multiples of 10. Specifically, I need to find which multiple is the smallest multiple that 4, 5, and 10 will go into evenly. So I start by finding the first multiple of 10. 10 times 1 equals 10. And I ask myself this question. Okay, will 10 go into 10 evenly?
Yes.
Yes. Will 5 go into 10 evenly?
Yes.
Yes. Will 4 go into 10 evenly?
No.
No. So we have to move on to the next multiple. And we do 10 times 2. What does that give me?
20.
20. So we ask ourselves that question again. Does 10 go into 20 evenly?
Yes.
What about 5?
Yes.
What about 4?
Yes.
Yes. They all go in evenly. So that is my LCM. My LCM, my least common multiple, is 20. Now that I have that piece of information, I can use it to go and get rid of all these fractions using simple multiplication. Everyone have this written in?
Yes.
By the way, there's not supposed to be anything here, that's just a blob. Alright. Okay, so now that we know what the LCM is, here's what we do. My LCM is 20. In order to get rid of these fractions, I'm going to have to multiply out the fractions. How do I do that? I start by wrapping both sides of the equation in parentheses. And then I'm going to take that LCM, which is 20, and I'm going to multiply both sides of the equation by 20. And when I do that, what you're going to see is that mathematically, all those fractions disappear just like that. Now, you got to be careful when you do it though. You must multiply everything inside the parentheses. So I'm going to multiply 20 times 2 over 4 and 20 times 6 over 10. And once you multiply, since this is a fraction, after I multiply, what do I have to do?
Simplify.
After I multiply, this is a fraction, what do I have to do?
Divide.
Divide. Here's what happens. Watch up here, everyone's eyes up here, watch what we do. I don't want you to miss it. Okay, what's 20 times 2?
40.
40. What is 40 divided by 4?
10.
10. 10, and bring down the n. Hey, there's one fraction gone. Anybody miss how that happened?
No.
20 times 2 is 40. 40 divided by 4 gives me 10.
Okay, I get it.
I move on to the next fraction. What is 20 times 6?
120.
120. 120 divided by 10 is 12. 10n plus 12 equals. Okay. One side down, one side to go. I do the same thing here. I multiply 20 times 4 over 5 and 20 times 15. So we repeat the process. Abby, what is 20 times 4? Gabriel?
80.
80. And then Montero, what's 80 divided by 5?
Oh, yeah, sure.
16. Thank you, Abby.
I think
16, and then we bring down the
oh,
n. Don't forget to bring down the n. And then one last thing. This is easier. It's just a whole number. What is 20 times 15? 300. Boom! There we go. And now we got something that looks nice, neat, and easy.
Good song.
We got rid of all those fractions, and the good thing is we know how to do this. We go back to the positive sequence that we learned to solve equations before. We draw a line right down the middle, and we're going to solve this equation one level at a time. So let's go to, just happens to be you, Juan D. Juan D.
Yes.
Okay, what are we looking at? What are you looking at right now in this equation? What do you got to do?
You have to find the smallest, the smallest.
We're looking at the variable terms, and you have to identify which coefficient is smaller. So what are your variable terms?
10n and 16n.
Okay, 10n and 16n. Which coefficient is smaller?
10n.
10n. So I must take this term, I move it over here. What's the opposite of a positive 10n?
Negative 10n.
Negative 10n. So I subtract 10n from both sides. I draw a line across the entire thing. Not just one little line here, one line there. And then I go back and I work from left to right to make sure I don't miss anything. I start here. What happens to the 10s?
They cancel out.
Cancel out. Then 1D, what happens to the 12?
It goes down.
I bring it down.
Bring it down.
I bring down the equal sign. What is 16 minus 10?
6n.
6n. And then what do I do with the 300?
You bring down the 300.
I bring it down. Okay. Now when you get to this point, here's what you should be saying to yourself inside your brains. Okay, brain, in this equation, I have all of my variables now on the right side. So that means all of my constants must move to the left side. So I look to the right side. Which one of these is a constant that I have to get rid of? 300. So what's the opposite of a positive 300?
Negative.
Negative 300. So I subtract 300 from both sides. I draw the line all the way across, and I move on to the next level of the equation. Once again, working from left to right to make sure I don't forget anything. What is 12 minus 300? Anybody?
Negative 288.
Negative 288. Good job. Negative 288. That's an 8. Equals, I bring down the 6n. What happens to the 300s?
Cancel out.
Cancel out. I have one final thing to do. Antonio, what do I do? What do I do now? I need to get n totally alone by itself. I have a 6n. I need to get rid of the 6. I divide both sides by 6. Why? What's the proper name for 6? Starts with a C. Good. I divide both sides by my coefficient. Those will cancel, and I'm left with n is equal to, anybody?
48.
Negative 48. Don't forget, when you divide a negative and a positive, make a negative. Good. Any questions on that one? No. As you can see, yeah, once we got rid of the fractions, it became super easy. If you have fractions, you must get rid of them first. Yes, Nicole?
Okay, so you have to multiply 20 and 15 together?
Yeah.
Okay.
Once you find the LCM, you wrap both sides of parentheses, you multiply everything in the parentheses by that LCM to
Okay.
get rid of all the fractions. And because what we do on one side, you must do on the other, we multiplied everything here by 20, you must multiply everything here by 20, including the whole number, okay? Unfortunately, a common mistake is people multiply, and they forget one thing, and then the whole equation is thrown off balance because they forgot to multiply one term. You must multiply everything, okay? If there's no, as you see later, there's a rare circumstance where you may not be multiplying everything. I'll explain to you why that happens. Right now, just realize you are multiplying everything, okay? All right, let's try another one here. We got fractions. We got 5/6y plus 1 equals negative 1/2y plus 1/4. Nobody likes fractions, so let's get rid of them. We look here and we identify the largest denominator. I give you a ticker.
Yeah.
Okay. The largest denominator is
6.
Caitlin. What's the largest denominator?
6.
6. Okay, that's my largest denominator. And Christian, Caitlin. Caitlin, what are the multiples of 6? What's 6 times 1?
6.
6 times 1 is 6. So we ask ourselves the question: can 6 go into 6 evenly?
Yes.
Yes. Can 4 go into 6 evenly?
No.
No. We move on. 6 times 2 equals
12.
12. Repeat the process. Does 6 go into 12 evenly?
Yes.
What about 4?
Yes.
What about 2?
Yes.
Yes. So my LCM is 12. Once I identify the LCM, what is the next thing I have to do, Caitlin?
You have to draw the parentheses,
I wrap both sides in parentheses, okay?
and then make an exponent or fold.
It's not an exponent. We're just multiplying. I just make it small. But we're multiplying. You can make it bigger if you wanted to. We're technically, whatever, however way you want to write it, we're multiplying both sides by 12. However you want to write it. Okay? So we multiply both sides by 12. You got a question? Or you just wanted to help? Well, I have to go to the card, so we'll see. Gabriel!
Yes.
Gabriel, help me out here. We're going to multiply. What am I multiplying 12 by?
5 over 6.
5 over 6y. So what's 12 times 5? 60. And 60 divided by 6 is 10. Bring down the y. What is 12 times 1? 12. It's a positive 1, so it's a positive 12. We bring down the equal sign, okay? Matthew, K-Rock. What am I doing on the other side, man?
You're gonna do 12 times negative 1.
12 times negative 1 gives me
Negative 12.
negative 12. Negative 12 divided by 2 is
Negative 6.
negative 6. Don't forget about the
Y.
y. So negative 6y. And then what else do I have to multiply 12 by?
Then 12 times 1
12 times 1 is?
12.
12 divided by 4 is?
3.
3 plus 3. And bam! We got rid of all the fractions. Look at that. Fractions gone. Now it's nice and easy. Kenzie, the question is, can Kenzie help me? Can you help me? Alright, what's the first thing I want to do here? Draw a line. Visualize. One side of the equation, other side of the equation. Okay. Now what are you looking at specifically?
Which coefficient is smaller?
Which coefficient is smaller? So which coefficient is smaller?
Negative 6y.
Negative 6y. So what are you going to do with the negative 6y?
Added.
I'm going to add 6y
Both sides.
both sides. Okay. I draw the line, I move on to the next level. What is 10 plus 6?
16.
16y. What happens to the 12?
You drop it down.
I drop down the positive 12. I bring down the equal sign. What happens to the 6y's?
They cancel out.
These will cancel. What do I do with the 3y?
You add it.
I'm sorry, the 3. I
Drop down.
drop it down. Bring down the 3. I don't need to write plus 3 because I know it's positive. So I'm to this point. Now, if you're working ahead and you got yourself a fraction as an answer, don't worry, that's correct. This is rational numbers. I can have a fractional answer. The only thing you can't do is turn it into a decimal. Let's move on. And some of you are like, what? Did we do this correct? All right, so say it to yourself. All of my variable terms are on the left side, which means, Nicole, all my constants must be on the
Right side.
So I look to the left side, I identify what I need to get rid of. Which one of these is the constant?
12.
The positive 12. What's the opposite, the inverse of a positive 12?
Negative 12.
Negative 12. So I subtract 12. From both sides, I draw a line, and I move on to the next level of the equation. What happens to the 16y?
You bring it down.
I bring it down. What happens to the 12?
Cancel that.
Cancel, I bring down the equal sign, and then what, Nicole, is 3 minus 12?
Negative 15.
Hold on. What is 3 minus 12?
Oh. Negative 9.
Negative 9. Okay. Negative 9. And don't forget, that's a y.
Forgot the Y.
Okay.
I always forget that.
So we have 16y equals negative 9. Now, I need to do one more thing in order to get rid of the coefficient. Allison, what do I do?
Divide by 16 on both
I
sides.
divide both sides by 16. And so far, you've always been used to getting whole numbers as an answer. You will not have a whole number here. You will have a fraction. You will leave it as a fraction, not a decimal. You will leave it as a fraction as long as the fraction is simplified. So these will cancel. And I'm going to have y is equal to negative 9 over 16. Is that a simplified fraction? Is that as far as it goes? Yes.
Yes.
That is as simplified as you can make it. So your answer is y equals negative 9/16. Do not turn it into a decimal. What's up?
So always like leave it like that, don't do this.
Yeah, if you get a fraction as an answer, you can just leave it as a fraction. Now, there will be times where we're working with decimals in the problem. If you get a decimal as an answer, then that's fine. But if you have a fraction as an answer, just leave it as long as it's simplified. What's up?
So if you can't simplify like you can't do what you just did, like divide it, just leave it as the fraction as it is if it can't be simplified.
As long as it's simple, if you can't simplify, yeah, leave it just like that. Okay. Any questions on this one?
No.
Okay. One more to go, just to make sure we got this down. And we're gonna go to Mr. Cedric.
No.
I'm taking off the training wheels. You tell me. What am I looking for? What am I identifying as?
10.
10 is my what?
Largest denominator.
10 is my largest denominator. What do I do now?
10 times 1.
10 times 1 is 10. Is that going to be my LCM?
No. 5.
10 goes into 10.
Oh yeah.
5 goes into 10 evenly, right? So is that my LCM?
Yeah.
Yeah, that's my LCM. Now, what do I do with my LCM, Cedric?
You put the parentheses and you put it in half better.
Parentheses, parentheses, and I multiply both sides by 10. Okay. So I'm going to multiply both sides by 10. And Jonathan's not here, so let's go to Wanji. We ain't in the school no more. All right. Abby. Abby. Abracadabra. 10 times 3 is
30.
30. Then, what do I do here? 10 times
4.
is
40.
40 divided by 5 is 40 divided by 5 is
Oh, 8.
8. So it's positive 8, and don't forget to bring down the
B. Oh,
B.
sorry.
Oh, sorry.
equals. All right, other side, Abby. What am I doing? 10 times 9 is?
94.
And just Abby, 90 divided by 10 is? No. Just the person I'm speaking to, please. 9B. Okay. Once we get here, oh, I didn't. Okay, once we get here. Okay, once we get here, 1D. I draw my line.
Yeah, you draw your line.
What do I do?
You have to find the coefficient, the smallest coefficient.
Okay, so which coefficient is smaller?
8.
8. So what's the opposite of the inverse of a positive 8?
Negative.
Negative 8b. I subtract 8b from both sides. I draw my line and I move on to the next level. What happens to the 30?
The 30 comes down.
I bring it down. What happens to the 8s?
You cancel them.
Cancel. And then please pay attention before you start writing this in so you don't make extra stuff for yourself. What is 9 minus 8?
1.
1. And 1b, if it's positive, 1b is the same as just b. As long as you end up with a positive variable, that's fine. What if I were to have, this is the answer by the way, b equals 30. Write this and I want to ask you a question about what would happen if I had something very close to this but just one thing different. Everyone have this written?
Yes.
Okay, so what if, let's just say, what if I didn't end up with a positive b? What if I ended up with a negative b? Could I leave that?
No.
No, I cannot leave a negative b. I have to have a positive variable. So what would I do in this case? Kristen, what would I do if I ended up with a negative b? Well, is there an invisible coefficient there? Yeah, so it becomes negative 1b. And then what would you do to get rid of that negative 1? What's the opposite of multiplication? Division. So I would have to divide both sides by, it's not just 1, it's negative 1. I would divide both sides by negative 1, and I would then get my answer, which would be b equals negative 30, okay? So just be careful. If you get a negative variable as an answer, you must go in and get rid of that negative 1 before you're done. But good thing is this was positive. I don't gotta do that, so I can just leave it like it is. Any questions on this one?
No.
Any questions? All right. Let's see if we can put what we just learned to the test. 4, 3, 2, 1 on this. All right, so now we're moving into equations with rational coefficients, not just fractions, but now we also got decimals. The good thing is, if you understand how to solve regular equations, variables on both sides, and you have your trusty friend the calculator, this won't be a problem for you because all the steps are the same. There's no multiplication to do, there's no nothing. You're doing the exact same process. So it's actually just some additional practice. We're still doing the same thing. We identified. Do we have any like terms we can combine? Yes or no? No, we do not. I cannot combine these two. I cannot combine these two. So I move right into the next step. I look at my coefficients. And Ben, which coefficient is smaller? 2.25 is smaller. So that means I'm going to take this term and move it to the right. What's the inverse, Ben, of 2.25?
Or subtract.
Yes, subtract 2.25t from both sides. Tip of the day, don't lose track of the decimal places. You should be using a calculator, so it should be easy. We do this and we work from left to right. What happens to the 2.25s?
They cancel out.
They cancel. And then class, what do I do with the positive 5?
Bring it down.
Bring it
Bring it
down.
down. I bring down the equal sign. 13.5 minus 2.25 is 11.25t plus 16, okay? So now that we're at this point,
16.
14, sorry, whoops. Good catch. That was just a test, you guys, to make sure you were paying attention.
Mr. Wilson, is that a T or?
It's a T. It's a T. It's a weird mangled T, but it's a T.
So it's
Okay,
E.
Laura.
What? Oh.
Now we say it to ourselves. Say it in the brain right here. We say, all right, I have all of my variable terms on the right side, so all of my constants must be on the left side. So looking here, which term has to go? The 14, the positive 14. What's the inverse of that? Negative 14, so I subtract 14 from both sides. I get rid of this smudge that I put over here. I make this look more like a 4, less like a pitchfork. All right, and then we draw the line. We work from left to right. So what is 5 minus 14, Laura?
-9.
Negative 9. bring down the equal sign, bring down the 11.25t, and the 14s
Cancel out.
cancel out. Now that I got to this point, Caitlin, what do I do?
You have to divide, that
Divide both sides by
by 9, no, by 11.25.
the coefficient, which is 11.25. So I divide both sides by 11.25, and I should get a nice whole number as my answer. Maybe, maybe not. Let's see. What is negative 9 divided by 11.25?
0.0.
Negative 0.8.
Negative 0.8. No whole numbers there. Good. We can have decimals.
Oh,
Notice that this is not a fraction that I'm turning into a decimal. I was working with decimals. I had to divide out a decimal coefficient. So in this instance, I can write this as a decimal. Yes, Andrew.
So if there's decimals in the equation, in the equation, you can write the answer of the decimal?
Yeah, you can write the answer as a decimal.
But if there isn't then?
If there isn't, no. It's just fractions, just leave it as a fraction. In this case, there was a decimal here. I'm dividing out the decimal. So I can actually write that as a decimal. Okay? Alright, we good on that? We're good? We're good? We're good. Alright. Okay. Alright, questions on this one? Nothing new is here. As long as you have your calculators, you should be straightforward with this. Just throw it in. Now! Yes, Juan, do you got a question? Did you have a question on the previous one? Want to go back? No? Okay. We're on a word problem now. We need to take this, and before we can solve it, we actually have to write the equation. And we want to write an equation that can be used to find the number of months after which the internet service would cost the same. So that basically means that we need to write an equation that sets fast equal to quick, the name of the two companies in the problem. So we need to write an expression for fast, we write an expression for quick, we set them equal to each other, and we solve. Anybody want to take a shot at what they think the expression would be for fast internet? Nicole?
30 plus 52.45x.
Perfect. I pay the $30 installation one time only. However, because I'm trying to find the number of months, depending on the number of months, this 5245 could change. So my variable will be next to the 5245. So 30 plus 52.45x equals, and then Nicole, what's on the other side?
57.45x.
57.45x. Okay, good. Now that I'm here, Allison, what do I need to do?
Draw the line.
Draw a line. Let me know that I got two sides of an equation here. Gotta keep it balanced. Gotta do it. All right, Allison, what are you looking at? Tell me, what are you looking at?
Subtract 52.45x.
All right, she identified that this was the smaller coefficient, so she is going to subtractify this thing on both sides of the equationification. Minus 5245 minus 5245. Don't forget the x. On both sides, draw a line. Move on to the next level. Work from left to right. We bring down the positive 30. What happens to these guys?
Cancel
Cancel
out.
out.
They will cancel. I bring down the equal sign,
5.
and this is 5x.
X.
Don't forget the x. Okay. And Sebastian, what do I do now?
You divide 5 by both sides.
I divide both sides by 5. And I get x equals, I'll say it, x equals 6. But Abby, what does that mean in the context of this problem? We have a problem here, right? What does that mean in the context of this problem? What were we
Oh,
being
you
asked
just
to
put
find?
dollars.
It's not dollars. We're talking about what? What were we being asked to find? Abby, look at that second little paragraph right there. What were we being asked to find?
Oh, wait, the one on the,
Yeah, what are we being asked to find? It says it right here.
oh. Number of months.
Number of months. So that means that after 6
6
months,
months.
the cost of these two internet services would be the
Same
same.
amount.
So I wanted to say the answer, I didn't want to say that.
Well, that is the answer.
But I wanted
X equals 6 is just part of it, man. That's just the algebraic
Oh
answer.
my God.
We gotta know the real world answer. You gotta know, let's say that years from now, Abby's trying to choose between Comcast and DirecTV.
AT&T.
Or AT&T. And you're given two different packages. And one of them gives you free installation, but costs less per month. One of them gives you free installation, but costs more per month. One of them gives you a charge for installation, but costs less per month. And you gotta figure out, all right, well, how long do I actually have to have this internet before I make my money back? By solving this little equation right here, which I know 10 years from now, you're like, all right, let me write an equation for this. 6 months will be equal. All right, I'll do it. I'll book it for a year. I'll save $30. That's fine. It's all about you saving your money. And that's another reason
Math matters.
I got 2 people saying it.
Math
Math matters.
Like what math? Math matters. Why? Why does math matter?
Because you save money.
Because you save money.
Money live better.
Walmart.
Save
Alright, so now we're moving on to 7.3. We're going to use the distributive property. Now, the good thing is, because if we back it up a second to what we were doing here with the fractions, you already know how to do the distributive property. All the distributive property is taking what's on the outside of parentheses and multiplying it with what's on the inside of the parentheses. So that's what we're going to be doing here. In this equation, as you can see, unlike most of the ones that we started with, we actually are given parentheses inside of the equation. This means that we have to distribute what is on the outside of the parentheses to everything on the inside of the parentheses. The reason I say this is that's a common mistake. I'll get something like this, 3x and then minus 5. Is this going to be 3x minus 5 when we multiply it?
No.
Absolutely not. But if you forget to do that, multiplication, you're going to do the rest of the work and everything else you do is wrong. So you have to be careful. So, let me ask you a quick question. Kenzie, what's happening between the 3 and the parentheses? What operation? Multiplication, yeah, multiplication's happening. So when we distribute, don't overthink it, you're just multiplying everything on the outside by everything on the inside. What's going on?
Can I borrow Benjamin for 1 second?
Yeah. Yeah. Back it up. Shoot the video. You gotta back it up. The reason I do this is because it lets me know when I'm going through the video very quickly where to stop, where to edit. That's right, multiplication. So when we're distributing, that means that we have to multiply everything on the outside by everything on the inside. So, watch me work. I'm going to take 3. Oh, before I do that though, I have to remember I have invisible coefficients, right? I have 2 of them right here. I have 2 invisible coefficients. Anyone see the one on the left side?
Yes.
In front of the one.
It's a 1, invisible 1.
Right there. And Marissa, where's the other one?
Right where the plus sign is, but with the X. There.
Okay, good. Alright, so I have blob. That has the belts right here. Alright, so I have those. Now let's go in and let's distribute out. So we want to distribute the 3 to the 1x and distribute the 3 to the, what is this right here?
-5.
-5. Be careful, it is a negative, not a positive, not 5, it's a negative. That's going to come into play when we multiply. What's 3 times 1x?
3.
3
X.
x. Don't forget the x. What is 3 times -5? -15. If I forget to multiply 3 times -5 and I just drop down the -5, am I going to get the equation right? No, that means that everything else I do all down here, it's already wrong. I haven't even done it yet, but it's already wrong. I bring down the +1, I bring down the equal sign, I bring down the 2 and the +1x. Now, we must harken back to 7.1 when you learn to combine like terms. After you draw the line, before you worry about the coefficients, you have to ask yourself, are there like terms that I can combine on the left or the right side? Does anybody see the like terms I can combine? Matthew?
The 15 and 1?
The -15 and the +1 are like terms. I can combine these, and in fact, it's not that I can combine these, I must combine these before I move on to the next step. So I will consolidate these 2 terms into 1. I'll bring down to 3x, and then can anybody tell me what is -15 plus 1? Nicole?
-14.
-14. I bring down the equal sign, I bring down the 2 and the +1x, and now I'm dealing with the type of equation that I like. I got a variable on one side, I got a variable on the other side, I got no more like terms to combine, I can start going through the routine. This one's not here either. Yeezy.
Yes.
Okay. Yeezy. What are you looking at? Tell me.
You subtract the 1x on both sides.
Subtract 1x on both sides.
Then that equals 2x minus 14.
Good. I work from left to right. 2x minus 14 equals
And then it cancels out. Wait, yeah. And then it's 2.
left to right. 2, and then these will
Cancel out.
cancel out. Okay. Now you say it with me. In this particular equation, all my variables are on the left side, so all my constants must move to the right side. So which one of these terms has to go?
14. -14.
I don't see a 14, I see a -14. So, Mr. Graham, what is the opposite of a negative 14?
Positive 14.
Positive 14. So I'm going to add 14 for both sides. 14, 14. Draw the line. I bring down the 2x. What happens to these 14s? They cancel. I bring down the equal sign. 2 plus 14 is what? 16. Okay, so we're good there. Ben! What do I do now?
Divide.
Divide both sides by 2. Divide by 2. Divide by 2. And x will equal ESP and 8. The Ocho. The channel nobody watches. All volleyball all the time. X equals 8. Any question on this?
Nope.
X equals 8. I was waiting for that look. Good job on this one. X equals 8. Does everyone have this? Any questions? The only thing new was we introduced parentheses at the beginning of the equation. Everything else is stuff you've done before. Question?
Oh, I hit myself faster.
Alright. Just call on him. Kristen Ann. Kristen Ann. First thing I need to do here in this equation, steps to solve. What's the first thing I got to do here? Step 1. What does it say? Distribute. What am I distributing? See where the parentheses are? That's where we're distributing. So what am I distributing? What's on the outside? 2 times 2x and 2 times positive 2. Okay, so Kristen, what is 2 times 2x? 4x, perfect. And what's 2 times 2? Positive 4, okay. And then I just bring everything else down. Positive 1 equals 2 plus 2x minus 3. That's a minus. Alright, now that's been butchered, so I gotta fix it. It's gonna drive me crazy. I draw the line, and I move on to the next step. I identify there's any like terms I can combine, so let's go to Montero. Do you see any like terms I can combine on the left side?
Yeah.
What are my like terms?
4 and 1.
You mean positive 4 and positive 1?
Yeah.
Okay. I consolidate these into a single term, and what do I get?
5.
5. I bring down my 4x. Don't forget that's positive 5 and the equal sign. Okay, good. Laura. LP, licensed product. Laura, are there any like terms I can combine on the right side of the equation?
No.
Remember, positive, negative doesn't matter. Do you see any constants on the right side?
2 and
And those are like terms. I can combine the constants. So what's 2 minus 3, Laura? I can consolidate these into what?
-1.
Negative 1. Perfect. I consolidate these into a single term. That's negative 1. I bring down the 2x. And now I have the type of equation that I'm looking for. Yes, Nicole?
Okay, so it doesn't matter if it's like not next to it.
No, it doesn't have to be next to it. I could have 20 terms. All I care about, okay, I got my variables, they're all like terms. My constants, they're all like terms. And I want to consolidate it into, I don't want to have any more than 2 terms on this side and 2 terms on that side when I'm solving an equation with variables on both sides. That's the most. Here I had 3 terms and 3, there's got to be something I can combine there, all right? That's kind of a tip. If you see 3 terms on one side, there's something there that you can combine at this level of algebra. There is, okay? So identify what it is, combine them, move on with your life. All right, Allison, hey, we're on you. What are you looking at?
And now you subtract the 2x
Good.
on both
This is a
sides.
smaller coefficient. I subtract 2x on both sides. Draw a line and move on to the next level of the equation. What is 4x minus 2x?
2x.
2x. What happens to the positive 5?
It goes down.
I bring it down. I bring down the equal sign. What happens to the 2x's, Allison?
They cancel out.
They cancel, and I bring down the negative 1. Okay. Marissa. So happy. Marissa.
That's my name.
Marissa
Ooh,
will
that
soon be starring on
That was
ESPN
cool.
The Ocho. All volleyball, all the time. Marissa, what do I do now? Say it with me. All my variables are on the left side, so all my constants must be on the
right side.
Amen. Hallelujah. What's the opposite of positive 5?
-5.
Negative 5. Hallelujah. Can I get a witness? What do I do with the 2x?
You bring it down.
I bring it down. What happens when 5
Cancel
negative
out.
5? That goes down. Everything bring an equal sign. Okay, and I have the negative 1, negative 5. What did I say? What did I say? What did I say?
-4.
Negative 4. That is incorrect. That is incorrect. And what have the correct answer for me? Negative 1 minus 5 is
-6.
what? Negative 6 is correct. Negative 6, negative 6, negative 6. And now at this point, what do I do with the equation? What do I do right now? What do I do? What do I
You
do?
divide
What do I do?
divide up 2x,
Divide
divide 2x.
X
equals -3.
Combination 2. Combination 2 is what? Combination 2?
You cancel out. They cancel
Combination
out.
2 is what? Combination 2? Coefficient. I divide both sides by 2. That's my coefficient. I went over with X. Equal to negative 3x. And I'm done. Yes. That's my answer. X equals -3.
You
The
scared me
fastest
so
minute in
fast.
math.
How do you do that?
Yes! We have learned Math Today video. Questions on this one? Questions? What you thought you were going to be done so quickly? We are going to bypass this one in the intro. And we're going to move on to this one.
Mr. Wilson.
Actually, nah, you know what? Let's back up. Let's back up here. Let's do this because some of you, I can tell, have already been working hard on your notes. So now, if you notice here, we had distribution just on one side. Here I have it on both sides. So I must distribute both sides. So follow along with me. In the interest of time, I'm going to tell you what we're doing. First thing is, we draw the line. Then I need to distribute. So I look on the left side. I have a 3. Inside the parentheses, x minus 13. I write in my invisible coefficients. What goes here?
1.
And what goes here?
1.
1. And then we go through and we distribute. So I do 3 times 1x. That gives me
3x.
3x.
Minus
3 times negative 13 gives me
39.
negative 39. A positive and a negative make a negative equals. Negative 8 times 9 is, anybody?
Negative.
Negative 72.
Negative 72. And then negative 8 times 1x is?
Negative 8.
Negative 8
X.
x. Okay. I got to this point, distribution's done. Then I identify my smaller coefficient. Quantity, which one's smaller?
8x.
8x. So I'm going to add 8x to both sides.
Uh-huh.
Add 8x. I add 8x. I draw my line and I work from left to right.
So it's
3
11x.
plus 8 is
11x. You
11x.
bring down the 39.
Negative 39.
Yeah.
Bring down the.
Equal sign.
Bring down
Then you
the.
bring down the negative 72.
And
Then
these
they
will
cancel out.
cancel out. All right.
And
And
then.
then.
So.
And then,
You
I have
have-
all of my variables on the left side, so all of my constants have to be on the
Right side.
side. So what term am I getting rid of here?
Negative 39.
What's the opposite of that?
Positive 39.
Positive 39. I add 39 to both sides right there, and I add 39 right here. And I'll bring down the 11x. What happens with the 39s?
They cancel out.
They cancel. And then just quantity. What is negative 72 plus 39? Anybody?
Don't tell me Mr. Wilson, I got it.
Sebastian, what is it?
Negative 30.
Negative 33. 33. We divide both sides by my coefficient, which is 11. And 11, I end up with x is equal to?
Negative
3. Once again. Did anybody notice what happened here?
We got the same answer.
What happened?
The same answer.
Got the same answer. Got the same answer here. Got the same answer. Here. Negative 3.
Oh, it's not good.
Okay.
Smells like coffee.
The last one here. The reason. Oh, go ahead. The last one that we're going to do in a second, you're going to see there's one thing different. Now we're going back to the beginning of this lesson, and not just distribution, but now we're going to have a fraction. And how do we get rid of fractions? What do we have to find?
The least common multiple.
We have to find the least common multiple. So we look at this problem here. I have 3/4 parentheses x minus 13 equals negative 2, 9 plus x. The good thing is here, I've only got one fraction. So that means that my least common multiple has to be, anybody?
4.
Has to be 4. I've only got one fraction, that has to be my LCM. I can make that a fraction, put it 2 over 1, but does that change anything? No, least common multiple of 4 and 1 is still 4. But now here's what's different. Now I'm wrapping, because I already have parentheses, I have to wrap both sides in these brackets. Brackets, 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 brackets. Doesn't really change much, but there's one little trick. Remember I said what you do on one side, you have to do on the other. We're still doing that, but you have to be careful. When you have parentheses, we're multiplying both sides by what, by the way?
4.
4. By 4 and by 4. I'll let you guys write that. I want you guys to pay attention here.
Wait, Mr. Wilson, so you get the bottom number to...
Yeah, that's always where you find your LCM. Because we only have one fraction here, your LCM is going to be whatever the denominator is of that one fraction. Now, what I want to point out is that before when we were doing this, we just had parentheses. But now I have parentheses that are inside of brackets. What does that change? It changes one small thing. When I multiply both sides, I'm only going to be multiplying 4 by what is outside of the parentheses. Only what's outside. And you're going to look, wait, what about what's inside the parentheses? We're going to come back to that in 1 second. But right now, you only multiply 4 by what is on the outside of the parentheses. So we go through the process. What's 4 times 3? 12. 12 divided by 4 is 3. You could also have just done it by canceling out the 4. That's still going to give you 3. 3, x minus 13 equals, what is 4 times negative 2?
Negative 8.
Negative 8. And you just bring down the 9 plus x. Once we've gotten rid of the brackets and the fractions, therefore, now we will go back and distribute to what's inside of the parentheses. But if you look closely, did you notice what's here?
Yeah.
Well, if you look closely, anybody else notice what's happened here?
Yeah.
What do you notice?
Hmm?
What do you notice?
That the first one is the same as the last question.
Yeah, this question is the exact same as
Did you do that on
this
purpose?
question.
Oh.
Wow.
Did you do that on purpose?
I did do it on
Well, I know the answer.
purpose. What's the answer?
-3.
-3. -3
Maybe you should do that on
is,
purpose.
in fact, the answer.
Oh wow.
Oh, that was so fun.
Mr. Wilson,
Yes.
can you do that on a test too?
For every question.
I know, right?
Every question?
Yeah,
No,
that
I
would be
mean,
No,
so much
because I got
easier.
one question wrong.
If you got one question wrong, then the whole thing's wrong, right? That wouldn't work out well for you.
Oh my gosh, imagine if you got like the first question wrong. Like, oh, I know this.
So we get x equals negative. I won't solve it again because we have to work on the previous slide, but just keep this in mind. Now, here's what we're going to do. Good afternoon and welcome to a special session of Mr. Wilson's Mathemagics. Today, what we're going to look at is we're going to finish up 7.3. We're going to figure out how to solve word problems using the distributive property. So this problem right here states that a taxi company charges $2.25 for the first mile and then 20 cents per mile for each additional mile. Or it's modeled by this, where F is the fare, $2.25 for the first mile, 20 cents for each additional mile. What we want to do is we want to figure out if Juan's taxi fare was $6.05, how many miles did he travel in the taxi? So what we're going to do is we're going to take $6.05 and we're going to substitute it into this equation for F. So I'm going to do that now. I'm going to write 6.05 is equal to 2.25 plus 0.20 m minus 1. What I need to do right now is I need to very quickly get rid of these parentheses. I don't like parentheses. I don't feel them. I don't like them. I want to get rid of them. I want to distribute the 0.2 to the m and the -1. So let's take care of that first. We're going to draw our line, and we're going to distribute out this 0.20 to the m and this 0.20 to the -1. When I do that, I will get a positive 0.2 m, and then 0.2 times -1 gives me negative 0.20. Now I go and I bring everything else down. I'm going to bring down the 6.05, I bring down the equal sign, and I bring down the 2.25. Once I get to this point, I want to go and I want to see if I can combine like terms. On this side of the equation I can't, but on this side of the equation I can. I can combine 2.25 and negative 0.20. The reason I can combine them is because they are both constants. They don't have variables, therefore these are like terms. If this term had a variable, then it would be a like term with this term. But because neither of them have variables, they are like terms, I can consolidate them into one term. So I'm going to subtract 0.20 from 2.25. That will turn into 2.05. Then I go ahead and I bring everything else down. I have 6.05. I bring down the 0.20 m plus 2.05. Now that I have my variable terms together, I want to get my constants on the other side. The way I do that is I subtract out the term that I don't want, negative 0.205, negative 0.205, and I work from left to right. 6.05 minus 2.05 gives me 4. I bring down the 0.20 m, and these will cancel. The last thing I have to do is divide out my coefficient, and when I do that, I divide both sides by 0.20, 0.20, and I'll end up with how many miles Juan traveled, which is m equals 20. So Juan traveled 20 miles. Not a long trip, but long enough for him to be charged $6.05. All right, so in this case, the equation was written for us. What if we have something where the equation is not written? Looking at this scenario, Sandra saves 12% of her salary for retirement. This year, her salary was $3,000 more than in the previous year, and she saved $4,200. what was her salary the previous year? Okay, well I have a percent here. When I'm going to use a percent in an equation, the first thing that I have to do is I have to turn it into a decimal. The way I do that is I start on the left side of the percent and I move the decimal. I have 12% here. I need to turn that into a decimal. The way that I do that is I write 12%. I start at the percent sign because there's no decimals here, and I might move my decimal 2 spots to the left. That's going to give me 0.12. That I can use in an algebraic equation. 12%, not so much. So now that I know that 12% is 0.12, I need to set up the equation. So this year, her salary was $3,000 more than in the previous year. All right, so we know that her salary was $3,000 more. We can write that. What we're going to do is we're going to use S for her salary. We know that this year her salary was $3,000 more. More indicates addition. And in the previous year, she saved $4,200. One last thing, I gotta go back and I have to figure out what am I gonna do with that 0.12? Well, this is distribution, so what I'm gonna do is, because Sandra saves 12% of her salary, and this year her salary is $3,000 more than it was last year, I'm gonna wrap this in parentheses, and I'm gonna put the 0.12 out here. Now I'm gonna distribute that to both terms inside the parentheses. I'll get 0.12s plus, you know what 0.12 times 3,000 is? That's right, it's 360. So I draw my line. Now I want to get my variable term, my 0.12s alone. By the way, that's a 0.12. Let me clean this up a little bit. It looks a little messy. Just so we're clear, this is a 0.12s. 0.12, that's an s. Plus 360. I need to get this term alone, so I'm going to subtract 360 from both sides of the equation. I'll bring down my 0.12s. These will cancel, and that's going to give me 3,840. The last thing I need to do here is divide both sides by, remember this is 0.12s. The variable here is s. I divide both sides by the coefficient, which is 0.12, 0.12, and when I do that, I'll know what her salary was in the previous year. I'll know that S is equal to, figure it out yet? I'll wait. You got it? That's right. Her salary last year was $32,000. And that's it. That's all you got to do. We set up the problem, we distributed, we found the answer. I want to thank you for joining us this time. Make sure you tune in next time when we talk about why math matters.